All right, we are in the section involving radicals and rational exponents. So now what's going to happen is we're going to take what we just learned about all of your rules, and we're going to make the powers fractions. Sounds fun, doesn't it? I know it does. I know you're also excited. So what are you going to learn? You're going to learn how to find nth roots. You're going to learn how to evaluate expressions with rational exponents. That means exponents that are fractions. And you're going to solve real-life problems involving rational exponents. So this is a lot of stuff here. A lot of stuff. So we're going to take this slowly. Finding nth roots. Now, nth root, I know you guys have done before, like square root. What's the square root of 4? What's the cubed root of 8? But we're going to talk about what happens when you're doing the 5th root, the 8th root, the 27th root. So we're going to take this a little further. You can extend the concept of a square root to other types of roots. For example, 2 is the cube root of 8 because 2 to the 3rd power is equal to 8. And 3 is the 4th root of 81 because 3 to the 4th power is equal to 81. In general, for an integer n, so n is an integer, greater than 1. So b to the n power, the power has to be greater than 1, is equal to a. If b to the n is equal to a, then b is the nth root of a. An nth root of a is written as the nth root of a. You're like, well, that's a square root. It's basically just a root, because here's what we're going to do. I'm going to write this off to the side. When you've written just like that, that's the square root of 8. Truthfully, though, there's a 2 here. And we've never written that 2, and that's okay. It's like saying the number 5. The number 5 has a power of 1. Everything has a power of 1. But we don't write the 1. So when you see square root, there's really a square there, a 2. So really, these are just roots, not square roots. So the expression n root a, or the nth root of a, is called the radical. This entire thing is called the radical. And n is the index of the radical. You can also write an n root of a as a power of a. If you assume the power of a power property applies to rational exponents, then the following must be true, and this is important. A to the 1/2 to the 2nd power. Remember your rule. Your rule states when you have a power to a power, you multiply them together. So a half times 2, 1, that equals a. A third times 3, that gives you a. A fourth times 4, that gives you a. Because a to the half is a number whose square is a, you can write the square root of a as a to the half. That's important. The square root of 16. You all know that the square root of 16 is 4. But you can actually write that as 16 to the 1/2 power. That's what this is saying. If you take the square root of something, that's the same as taking it to the 1/2 power. If you actually take the 3rd root of something, that's taking it to the 1/3 power. The 4th root is to the 1/4 power. And that's what it says here. Cubed root is a to the 1/3. The 4th root is a to the 1/4. So in general, here it is. The nth root of a is written as a to the 1 divided by nth power for any integer n greater than 1. All right, so let's talk about our core concept. The nth roots of a, so that means the nth root of a. So we're going to make sure n is an integer greater than 1 and a is a real number. So let's do all 4 of these cases, and I'm going to do examples underneath to help you out. So let n be an integer greater than 1, let a be a real number. So if n is odd, so let's say n is odd, and a has one real nth root. So here's what we're going to tell you. If n is odd, and a can be whatever, let's say it's 8, then you'd write it like this. You only have a positive. There's a positive cube root of 8. So what number times itself 3 times gives you 8? Your answer is positive 2. Pretty easy. Let's say the next one I tell you n is even. So n is 2, and let's say a is 25. That's pretty easy. We are then going to have a positive or negative number. And you're like, whoa, I thought the square root of 25 is 5. It is. But when you actually are given the n and the a and you set it up, there are two roots for this answer. So the positive or negative square root of 25, which can also be written as positive or negative 25 to the 1/2 power. So your answer is positive or negative 5. Let's say the third one. If n is even and a is 0. Now this one's pretty easy. The square root of 0. The 6th root of 0. It does not matter. This is just 0. But then if n is any number you want, and a is a negative number, you cannot take a root, an even root, of a negative number. This is what we're going to call imaginary numbers, which we're not going to talk about now. We'll talk about later. Imaginary numbers, please listen to me because this is confusing for people. The nth roots of numbers may be real or imaginary. In this case, it's imaginary. You will study imaginary numbers either later this year or in a future course. So, I'm going to go back to this one over here, this first one. We can write a to the 1/3 power here. If I change this to a negative, it does work. You would get negative 2, because negative 2 times itself 3 times gives you negative 8. The only time you can have an a value of negative is when the n value, the root value, is odd. So example number 1, find the indicated real nth roots of a. So, we just write them in as the nth root of a. So the third root, or the cubed root, sometimes called the third root, of negative 27. What number times itself 3 times gives you negative 27? Now, that would give you what? Negative 3. That's it. If you wrote it, you could also write it as negative 27 to the third. So you're going to be seeing me do a lot more of that. While you don't need to show that to get the answer, I want you to understand that this is what you're doing. Now notice what I just showed you, negative 27 to the 1/3. Make sure you have parentheses around it. So the next one, the 4th root of 16. The 4th root of 16 would be 16 to the 1/4, but because it has an even power, you get plus or minus 16 to the 1/4, which would give you plus or minus 2 as your answer. If you want to try these out on your own, you may pause the video and try this out. 1 would be the 3rd root of negative 125, which would be negative 125 to the 1/3 power, which would give you negative 5 as your answer. Number 2, the 6th root of 64. That will give you plus or minus 64 to the 1/6 power, which would give you plus or minus 2. All right. Evaluating expressions with rational exponents. This means we're going to start having fractions. Once again, we're going to evaluate nth root expressions. Now recall that the radical, the square root of a, indicates the positive square root of a. Similarly, an nth root of a with an even index indicates the positive nth root of a. This is where we're like, you're going to kind of get confused, and I know you're going to get confused here. We just said that the square root of 16 would give us plus or minus 2, right? Absolutely. However, if I already give you, this is where you're going to get a little lost, I think, but stick with me and we'll get through it. If I tell you that a is 2 and b is 16, that means I'm going to have a positive or negative square root of 16. Because I told you this. This, you plug it in, it's going to give you 2 different values, a positive and a negative, and that's how you get plus or minus the square root of 2. But if I give you this, or I give you just 16 to the 1/2, I'm only telling you that it's positive. So that's what it says right here. If you have an even index, that only indicates the nth root, the positive nth root. So if I'm telling you that, then it's just positive. So let's try this together. Now remember that the expression under the radical sign is called the radicand. So -8, 8, that's the radicand. So A, notice it's already been set up for you. This answer would be what times itself gives you -8 3 times. What times itself 3 times gives you -8? That'd be -2. B, now this one, notice what it said. It said, I want the positive cubed root. This one says the negative. So this one's actually going to give you negative, and then what's the cubed root of 8? It's 2. So then that one's going to give you -2. And if I actually showed the steps in here, let me move this. If you actually showed the steps, it'd look like this. 2 times 2 times 2. I mean, 2 times itself 3 times gives you 8. Now in C, this would be the 4th root of 16, which means that would give you +2. Now you're like, wait a minute, I thought I'd be plus or minus. Because I actually gave this to you, I'm just telling you it's plus or minus. And on this one is going to be the 4th root of -16. The 4th root of -16, you can't do that. It is not a real number because there is no real number that can be multiplied by itself 4 times to produce -16. So we're just going to, not possible. It's imaginary. We'll talk about that later. All right, our next core concept, and this one's confusing for students. Rational exponents. Let a to the 1 divided by n be the nth root of a. So the nth root of a. Now notice right here, let me write it here. This has always been 1. Now the bottom number, as you know, is your root. So this number is your root. But the 1 actually always goes there, which we've never talked about that yet. Now we're going to let m be a positive integer, and no longer is that going to be 1. It's going to be m. So a to the 1n, we can separate it, equals the nth root of a to the m power. So here's how it looks. 27 to the 2/3 power. The bottom number is always the root. But here's what we do. We have to undo this. Remember when we did this? 3 squared to the 4th. That would be 3 to the 8th. We multiply them. We're reversing it. So we're separating the 2/3 with the numerator. So this is going to be 27 to the 1/3. That means the cubed root of 27. And then the 2 comes out because 1/3 times 2 would give me 2/3. That's using your rules of powers. This would become the cubed root of 27. The bottom number is always your root, but now we take it to the 2nd power. So example number 3, students find this difficult. So just bear with me if you don't get it. But let's do A. 16 to the 3/4 power. That means what I do is take that. That's your root. So I'm going to do the 4th root of 16. The top number is what you're taking it to. So the power that you're taking everything to. So now you simplify. The 4th root of 16. Well, that's 2. To the 3rd power, my answer is 8. Now, there's another way you could have done this. You could have just done this. 16 to the 1/4 power, to the 3rd, simplified that to 2, and then taken that to the 3rd power. So let's try B. 27 to the 4/3 power. That would give me 27 to the 1/3 power, all to the 4th. Or you could write it as the cubed root of 27, all to the 4th power. Well, the cubed root of 27 is 3 to the 4th power. 3 to the 4th power is equal to 81. Here are some wonderful examples for you to try yourself. Number 3, the cubed root of -125. That would just give you -5. Number 4, -64 to the 2/3 power. That would give you the cubed root of -64 all squared. Well, the cubed root of -64 is -4 squared. That would give you 16. 9 to the 5/2 power would be the square root of 9 all to the 5th power. Well, the square root of 9 is 3 to the 5th power. 3 to the 5th power is 243. And the last one, the 4th root of 256, all to the 3rd power. The 4th root of 243 is what? It's 4. To the 3rd power gives you 64. Solving real-life problems, example number 4. The radius r of a sphere is given by the equation, and there's your equation. Now you're probably looking at that going, oh my gosh, look at that equation. Where v is the volume, and you need to find the radius of the beach ball to the nearest foot, and pi is 3.14. Now it tells you over here that the volume is 113 cubic feet. Step 1, understand what you're trying to find. You know the equation that represents the radius of the sphere in terms of its volume. You are asked to find the radius for a given volume. So make a plan. I would substitute it in. You're given the formula. So R equals 3 times, well, we're given the volume. The volume is 113. We also know pi, and pi is 3.14, all to the 1/3 power. So we substituted 113 for v and 3.14 for pi. Now we multiply the two numbers together. So 3 times 113 is 339, and 4 times 3.14 gives you 12.56, all to the 1/3 power. Now, we could then take the cubed root of the whole thing, but the best way to do this is, use your calculator. Graphing calculator is by far the best for this. So, 339 divided by 12.56 gives you a number. You take it to the 1/3 power, or the cubed root of it. You get r as the radius as approximately 3. So your final answer would say, right here, the radius of the beach ball is about 3 feet.